So today Forum Committee of AAUPCC invited a young scientist who is a product of University of Peradeniya. Is Dr. Padma Kumar Jayasinghe. So I warmly welcome Dr. Padma Kumar Jayasinghe. He's a senior lecturer, Faculty of Arts, University of Colombo, and he passed out from Faculty of Science, University of Peradeniya in 2000. And after completed his BSc special degree in Geology with a second class honor, he completed a BSc special degree in Geology with a second class honor degree. So after that, Dr. Padma Kumara followed MSc in Environmental Science and PhD in Earth Science in the same university. So during his career, he was worked at several organizations, and I would like to mention some of the institute he worked. So the first Department of Geology, I think assistant lecturer, and then Gem and Jewelry Research and Institute, the Training Institute at Ratnapura, and Central Cultural Fund, and COSTI, and finally NBRO. Actually, I known to him when he was working at the NBRO because we were under the same ministry. And at present, he is working as a senior lecturer at the Faculty of Arts, University of Colombo. And at the same time, he is doing some visiting lecture to the Kotalavala Defense Academy, Ranjirata University, Kalani University, and Rohini University. So during his career, he has done number of research publications, both local and international, for peer-reviewed journal. So today, Dr. Padma Kumara will deliver a short presentation. Probably it will be 30 to 40 minutes, geology for day-to-day life. So I hope this topic will be important to many aspects of your life. So with this brief introduction, I would like to invite Dr. Padma Kumara to deliver his presentation. So Dr. Padma Kumara, over to you.
Thank you, sir, our former DG, Mr. Sarat Premla. And good evening, ladies and gentlemen. I'm really happy to be here with you with these prestigious members of the alumni of Peradeniya Colombo chapter. So, Premla sir, can I share the
you can share.
I have given you the co-host facility. You can share this.
Okay, thank you very much. Can you see the screen now?
Yeah.
Okay, thank you very much. Today, actually, I'm going to talk actually a little bit about geology, which is very important for our day-to-day life. So these are very simple things, but maybe that can be important for your, work, day-to-day work. Sometime maybe you are interacting with the geology, maybe you don't know. Right. So thank you very much. Again, I can move to next. Okay. This I can start with this actually. If you can tell me what is this?
Yeah, this is a globe world.
Yes, actually. So you can see the Africa is there, and also the Asian region, and also this is the actual shape of the Earth. Even although we have an idea about that, we knew that the globe is perfectly rounded or spherical, but it is not. So this is the actual shape, and there are some important features. So you can see the colors. There are red color and the blue color. So these colors actually gives you an idea about gravity. So blue color gives the low gravity areas, and also the red color gives the gravity higher gravity areas. So the important thing is, so you can see in Sri Lankan area, as you can see in this picture. So the Sri Lankan area has the low gravity area, that is the lowest gravity area in the world. So this is very important for some aspects, like this is not the time to discuss about those things. This is very good for, you know, if you are doing some meditation or something like that. So this is a very good region for that. So simply, this is the shape about the shape of the Earth. So I will move to the next slide. So starting our talk. So geology is actually, of course, you can say it is also as Earth sciences, but in Earth sciences, there are so many subfields are included. So when we are talking about geology, is a branch of Earth science concerned with the solid Earth. It talks about the solid Earth and the rocks of which it is composed, and also the processes by which they change over the time. If you are talking about the processes, so we can point some processes like, you know, these plate tectonic, volcanic eruptions, and earthquakes, and also the hydrological cycle and other carbon cycle, and all the processes, you know, occurring in the Earth. So in the field of geology, so we are studying and also we are doing research on these kind of things. So fields are very important here. They are the materials by which the Earth is composed of, and also the processes. So we know that the Earth is a dynamic system. So this dynamic system is actually kept with these processes. So in this talk, I am going to talk about small, very simple things about very important things to our day-to-day life. So geological processes, few processes that are important for our day-to-day life, and also some geological materials which are actually at the moment we are using, but we don't know really we are using that, right? So in some cases, so I will come to that part later. So first of all, I will move to the geological processes which are important for our day-to-day life. So if you are talking about the processes, there are many processes like earthquakes, tsunamis, volcanoes, weathering, landslides. So all these processes are going on the Earth. So when we are talking about earthquakes, tsunamis, volcanoes, so these processes are actually connected with the main process which is known as plate tectonic theory. As a result of plate tectonic movements or the plate tectonic activities, earthquakes, tsunamis, and volcanoes are occurred. So if you are talking about landslides, actually landslides are correlated with the weathering processes. So weathering processes is one of the processes that is going on the surface of the Earth. So these are some processes. So we will go to some processes. Before that, I think I would like to I should give a brief introduction about the Earth structure. So when we are talking about the Earth structure, so it is composed of 3 layers. So as you can see in the left and right side, so you can see the avocado, cross-section of avocado. So that is very similar to the Earth structure. Earth structure is similar to the layers of avocado. So you can have the outer layer and the middle flesh, and also the seed. So similar parts, similar layers, very similar layers can be seen in the Earth structure. So Earth structure can be categorized into 3 layers. They are the crust, the uppermost layer, and also the middle layer is the mantle, and also we have the core. This structure is very similar to the structure in the Venus and other planets, mostly the solid planets in the solar system. So when we are talking about the crust, actually the crust again can be categorized into 2 parts: continental crust, where the continents exist, and also the oceanic crust, where we have the oceans. So when it comes to the mantle can be again categorized into 2 parts: upper mantle and the lower mantle. Again, the core, same as the mantle, again it can be divided into 2 parts. outer core and the inner core. So the outer core and the inner core are very dense. They are actually composed of nickel and iron like materials. They are very dense, and also the crust is the less dense part. It actually, we can say, it floats on the mantle, right? It mantle. So this is the structure of the earth. So again, another wedge, cross-section wedge. So you can see the pleats. So there are some crusts. So you can see this brown color part, and also the plate under the ocean is known as the oceanic plate, and plates with the continents is known as the continental plates. So the part of the upper mantle and also the crust combined form lithosphere. So lithosphere is a rigid part, and it can be known as plates. So the lithosphere is fragmented to form plates. So at the moment we have 12 to 15 major plates and also the minor plates in between. And just below the lithosphere, we have the asthenosphere, which is semi-solid, or which is a kind of a liquid form. And all the plates lie upon the asthenosphere are moving on this asthenosphere. So asthenosphere gives the kind of, it triggers the movements of the lithosphere or the lithospheric plates. So that is the basic part of when you are talking about the plate tectonic theory. So plates are actually composed of lithospheric materials, or what you call the crust, and also the upper part of the mantle, and it floats on the asthenosphere. So when you are talking about plate tectonics, so we have three boundaries which are very important because it determines the movements of the plates, whether they are moved away from each other, as you can see in the second picture, the second middle picture. So these are known as divergent boundaries. So in that case, at that boundary, most of the plates, they are moving away from each other. In that case, actually, the main thing is oceans are formed, or oceans are originated newly. And the second, the topmost picture or the cartoon gives you the boundary of convergent or convergent plate boundary. So it is in there, actually, plates are moving towards each other. So therefore, in that case, plates are collided to form mountains. So in that case, actually, convergent plate boundaries are the boundaries at which mountains are formed. And also we have the third one, the last cartoon, as you can see. So that is known as the transform plate boundary, which is very, in that case, actually plates are moving against each other. So in that case, most of, the best example for this is actually the, we have fault, what you call, okay, so I will come to, I will tell you later. So in that case, actually, because of that plates are moving against each other, in that case, most of the earthquakes are taken place because of this kind of plate boundaries. Therefore, these plate boundaries are very important when we are talking about the dynamic earth, or what you call plate tectonic activities there. So the volcanism actually is a result of this kind of plates margins or the plate boundaries. So most of the cases, these volcanic eruptions are taken place at the plate boundaries of convergent or the convergent plate boundaries. So in that case, you can see one plate is moving downwards. Because of that, actually that plate, when it reaches to the suitable levels, so these plates are melted. Then it forms the flumes, or what you call the magma flumes or magma chambers. Then what will happen later? The later these magma flumes are coming up to form volcanic eruptions. So therefore, the place most of the volcanic eruptions are taken place at the convergent boundaries. This is very common. And when we are talking about the mountain building, again, because of the convergent boundaries, as I explained earlier. So one plate is moving upwards while other plate is moving downwards. Because of moving upward, that the other plate, therefore we get this kind of mountains. So mountains are built because of this kind of upwarding, or the what you call the moving upward of the plate, other plate. So tsunamis are actually occurred because of the same thing. So where we have a convergent boundary at the oceans or in the ocean. So where we have the oceanic plates, so two oceanic plates can be collided. So in that case, actually we know that they are, whether even though they are collided, so they are not, moving very fast. The movements is very slow, and also that movement can be restricted because of the abrasion and other forces in between these two plates. There is a time at which that the movement or the force of the push can be exceeded the abrasion or the force in between these two plates. In that case, that the one plate is moving very fast, giving us some kind of push to the pushing the water column upper water column of the ocean. So in that case, we get some kind of tsunami waves. So in that case, so we get the tsunami. That's how the tsunami is formed. So this is a very simple explanation about the tsunami and all. So I think you may understand that thing. So this is one of the best example for the mountain building, as you can see in this picture. So you can see the gradual formation of the gradual collision of the Indian plate. So Indian plate nearly 71 million years ago. So you can see that the Indian plate at the bottom of the picture. So it has been moved upward to north till it was collided with the Eurasian plate. Eurasian plate is the Eurasian plate is a big plate comparatively in comparison with the Indian plate. So because of this collision, Himalayan region has been formed. Still the Himalayan is going up or growing up because of the collision. So still this Indian plate is moving northward by pushing the Eurasian plate, but you know that the small plate, it cannot push the bigger plates. Therefore, what will happen is Indian plate is pushing up. I mean the Indian plate is moving upward or going upward. So because of that, the Himalayan region is moving up. So this may be the reason. So these kind of earthquakes, which are actually occurred at the plate boundaries are known as interplate earthquakes. And same as we can have the intraplate within the plate earthquakes. Now I think, according to my view, so Sri Lanka is experienced that kind of intraplate earthquakes during last few decades of time. Even last year, actually, or not only last year, even this year, we have experienced some earthquakes or triggers because of this reason. This can be the reason, not exactly, but I believe that this can be the reason for the earthquakes happening in Sri Lanka. Okay, so that is all about the processes, and I will move to the materials or the earth resources important for day-to-day life. So when we are talking about the materials or the earth resources, two things are important. The first thing is the minerals and also the rocks. So most of the rocks, or almost all the rocks, are composed of minerals. So minerals are the chemical compounds. They have a specific chemical formula, and also they have a specific crystal form, and also they are solid and occurred in a natural environment. At the moment in the world, there are more than 4,500 minerals have been discovered, naturally occurring minerals. So almost all the rocks are actually composed of minerals. So when we are talking about the minerals, there are some minerals. I have listed 20, but there are more than that. So which are useful for our day-to-day life. So the first thing is halite, feldspar, quartz, gold, silver. Of course, gold and silver are also the minerals. Hematite, when we are talking about hematite, and also there is another mineral which is composed of iron oxide, that is known as magnetite. Magnetite is actually that can be attached to the magnet also. And also gems, there are so many, I mean the varieties of gems we can see even in Sri Lanka. And also the very famous mineral graphite, and also the calcite, talc. And of course, we have mineral oil, peat and coal, and apatite, which is very important for these agricultural things, because it gives us the phosphate. And also the ilmenite, rutile, gypsum, mica, fluorite, malachite, pyrite, and kaolin. So there are so many other things, but I have listed these are very important. So these are very commonly used in our day-to-day life. So I will come to one by one, not all, but few. Where these minerals are used and useful for our day-to-day lives. Of course, we know that halite. Halite is the mineralogical name for salt, what we call sodium chloride. We know without salts, we can't, eat. So that is very essential for our day-to-day life. The figure gives you the picture gives you the crystal shape of the halite. So halite is actually, it is a chemical compound composed of sodium chloride, what we call. So it is a very common chemical compound in the seawater. So most of the salt which are needed for our day-to-day life are actually extracted from the seawater, but there are some salt deposits in the continental shelf can also be seen. So most of they are known as actually rock salt. So rock salt are a little bit brownish in color, or pink in color, or in between, like red, brown, pink. So that kind of colors can be seen because of the they are contaminated with the iron. So those are the rock salt. So salt, actually halite, is very essential for our day-to-day life, even though you are not aware of that the salt, or what you call the halite, is a mineral. The next thing is actually talcum powder. Of course, most of the ladies, actually, they are very fond of this kind of, talcum powders. So because and also some facial makeups, the materials you are using for the makeups and all. So those, most of the talcum powders and also these makeup materials are actually produced from the mineral called talc. So talc is the when we are talking about the hardness, so the according to the hardness scale, Mohs scale, so the hardest mineral is diamond. So this is the lowest hard mineral. Their hardness is very low. So the number given for the Mohs scale, in the Mohs scale for the talc is 1. So therefore they are very smooth, soft. So that's why actually the producers, or the what you call this industry, use this talc. So therefore, if you are that most of the time, so you are using this kind of talcum powder because they are very dry, therefore they can absorb water very well, and also it gives some kind of smoothness to your face. And also with the other this kind of different kind of flavors and all, I mean not the scents or the different kind of chemicals that can be that use the different odors and also. So therefore this talcum powder gives you some kind of good feeling, but that this talcum powder is made up of the mineral called talc. And also the jewelries. So most of the cases, that we are using different kind of jewelries embed with gems, different kind of gems. We have the corundum family gems like blue sapphire, yellow sapphire, padmaraga, pushparaga, geuda, and a lot of varieties. And also we have the diamond, but not in Sri Lanka. And also we have different kind of garnet varieties like, you know, Rabaha and other Hessonite garnet. And also we have the there are so many different kind of gems. So these all gems are minerals. And also to produce jewelries, we are using mainly two kind of metals. The first thing, or the topmost one, is the gold, and also the second one is the silver. Silver is very popular in the Western culture, but the gold is very popular in the Eastern culture, like you know, India and Sri Lanka. So these are actually minerals. So the silver itself is a native element, and also the gold itself is a native element. So these are native element minerals. So now today we are almost all of the people, we are using the smartphones, tabs, computers, and you know, so now the new technology is coming with this kind of devices, and day to day, I mean, even daily, these are, you know, getting updated, and new types of varieties, new types of phones, new types of computers are coming up. You know that these computers are actually made up of the tiny piece of uh, component called chips. So they are known as, again, silicon chips. Actually, the silicon chips are made up of silicon. Silicon is a semiconductor or semiconductor metal, so which is extracted from quartz. Quartz, the chemical formula of the quartz is SiO2. So from that, so we can extract silicon. The major or the main resource for the Silicon Valley is the silica. So we know that in Sri Lanka there are so many quartz deposits in the island. So at the moment, actually, these quartz are extracting, they are mining and exporting. The problem is they are sending those material as raw material, not as the what you call the value-added material. So if we can send them as value-added material, so we can earn a lot of money. We know that the 1 ton of silicon is you know, their price is very higher than the 1 ton of quartz. So, but unfortunately, at the moment, we are sending the raw material. But we know that every computer, every smartphone, every tab, so there is a silicon metal. So silicon metal is in the chips. So chips are made up of this kind of silicon extracted from the quartz. So when we are talking about the quartz watch, most of you are, you know, wearing a watch. You know that I don't know whether the young generation is now wearing because you know, most of the, you know, the watch is using for, you know, to you know, get an idea about the time. But you know, most of the, you know, the old people, I mean the previous era, so they are using these they are wearing the watch. So in the watch, so a specific name is given for that kind of watch is quartz watch. So earlier we had the you know, watches which should be you know, that we should have a kind of a, you know, winding. So otherwise the watch is not working. But in quartz watch, actually quartz, as you can see in this picture, there is small piece of quartz. Quartz has a specific property called piezoelectric property. So piezoelectric property is that normally quartz, it cannot pass the electricity. It is not a conductivity material. Their conductance is very low. Therefore, but the specific property with the quartz is they have the piezoelectric property. So that means if you give a kind of a stress in between two ends of the quartz crystal, so in that case, so the quartz can pass the electricity. And the same thing, or the reverse is again, you can have. So if you can give a kind of electricity, that the quartz crystal can be bent, right? So because of that, so that feature has been used in the quartz watch to keep the time, you know, in like, you know, equal time slots. So because of that, so if you are giving a kind of electric current to that quartz crystal in the watch, so what will happen once you give the current? So quartz, that crystal is bent. So that in that case, the circuit is broken. So again, what will happen since the circuit is broken, no electricity is there. So then what will happen again? That quartz crystal come back to the same position, connecting the circuit again. So again, it gives a kind of a current. Again, that circuit is broken because of the quartz crystal is bent. So this thing is happening over and over again. So because of that, it is and that thing is connected to the what you call this watch, the machine, and so it creates some kind of the similar or the equal time slots by having that kind of thing. So you don't have the delayed time. Of course, as when you wake up every day, so you go to the bathroom, and so you are you are brushing your teeth, and so we are using toothpaste. So you know that toothpaste is actually made up of several kind of minerals or geological materials, what you call silica, clay, calcite, and fluorite. So fluorite is added to give some kind of extra fluorine, and also calcite, clay, and silica are basically, silica is SiO2, or what you call the silica sand, and clay specifically kaolin, and calcite. Calcite is a common component of Kirigarunda. I will come to that part, what you call marble. So these kind of stone powders are using for toothpaste. So, but you know that our early people or ancient people, they have used charcoal, which has the less hardness than the teeth. So that's how they brush their or they clean their teeth. So you know that with this kind of technological thing or higher techniques or higher technologies, still we are using the same materials what our ancient people have used. So the plastic, we know that plastic is a problem, but it's in everywhere. So they are made up of crude oil as a result of the byproducts of the crude oil. Most of the plastics, actually the polymers, or what you call the they are the materials come with the large molecules that are actually extracted from the crude oil. So when we are what you call extracting other diesel and what you call these petrol and other the gases and other oils. So once they are we are the extracting those other materials from the crude oil, so we get byproducts from the crude oil. Using that byproducts, actually we can produce the plastic. So this crude oil actually again known as the black mineral or mineral oil. So again, we know that the crude oil is also used for energy production, and the same as the coal. We know that not in Sri Lanka, but in other countries we have the coal. Coal is actually buried forest. Coal is made up of buried land plants, but crude oil is actually made up of the organisms in the ocean. So they have two origins. The most of the crude oil, or almost all the crude oil, are made up of burial of marine organisms, but the coal is made up of land plants, burial of land plants. So we know that coal can be used for produce the energy as we are using in the Norochole, and also there are so many other uses in day-to-day life you know that if you want to have some kind of barbecue or something like that, so you are using this kind of charcoal. It's coal balls. And of course, we know that from your childhood, we all of well aware of the pencils. So pencils are actually made up of graphite. So graphite is a very famous mineral in the world, and not only the world, but in Sri Lanka we have several very good graphite deposits. One in Bogala, and we have the two other in the Kahatagaha and Kolongaha, and also there are some other locations in Kalutara. So in you know that Sri Lankan graphite, the purity of the Sri Lankan graphite is 99.99. So these are very pure materials. They are very, I mean, they are rich in carbon. And the important thing is, as I said, still we are sending those graphite, or we are exporting those graphite as raw material, not as value-added material. So if we can at least produce some pencils, and if we can export those pencils, so then it is a kind of a good thing, or good the achievement for that kind of value-added material. So when we are looking, but at the moment in some occasions or in some industries, so the people are using graphene. This is a kind of a value-added material using the nanotechnology. So graphene is now, I think, as I remember, a small amount of graphene is exported. Paints. We know that every year we need paints. We want to, you know, color wash. So, and also in other, you know, the houses and the buildings, and everywhere we need the paints. So paints are actually made up of specifically kaolin, what you call the kind of a clay mineral. The base is the kaolin. So in that case, you know, even though you are not aware of that, the materials, of course, the paint is made up of kaolin, which is again a kind of a geological material, or what you call mineral. Ceramic, maybe you are, you know, this is very familiar with you. You know that the ceramics are everywhere. So we are using plates, we are using cups and tiles and everything. So most of the, you know, materials are, day-to-day life we are using are made up of ceramics. Actually, the ceramics are product of few minerals like calcite, feldspar, and quartz. Okay, so these are very few things. So I think the minerals are, you know, these are the main minerals that can be used in the day-to-day life. So when you are talking about rocks, so I will come to that part. I think this is very important because, you know, most of you are, you know, visiting Anuradhapura, the sacred city. There is a very famous Buddha statue, which is known as Samadhi statue. So this is Samadhi statue is, you know, made up of very specific rock, which is known as marble, and in Sinhala it is known as Garuda. So it is actually a, you know, that should be, you know, known. And when we go to the Galviharaya, again these statues are made up of gneisses, and so there are so many other things if we are talking about, but I think I have come to the end of the session. So these are very simple things and very small, you know, part of the things I have covered. And so finally, I have to, you know, introduce my blog. So all those articles are, you know, uploaded in my blog, Vidyavindana, vidyavindana.blogspot.com. If you want, so you can go to the Vidyavindana. There are more than 250, I think nearly 290 articles. These articles have been already published in Vidusara. And also there are some articles, you know, that explaining the some geological sites and also the materials. So you can read if when you have a free time, leisurely. So you enjoy the Vidyavindana. And thank you very much. That's end of my presentation. And thank you very much for your patience and listening to the presentation. Thank you very much.
Yeah, So thank you very much, Dr. Padma Kumar. So the next item is to hand over memento to Dr.
Thank
Padma
you.
Kumar as a token of appreciation. So I would like to invite our president, Dr. Jampati, to hand over this memento to Dr. Padma Kumar. So
Yeah, Doctor. Thank you, Premalal, arranging this kind of very informative and very valuable short presentation. And thank you, Doctor, delivering us and updating us with this kind of very knowledgeable session. And please accept on behalf of AAUP Colombo chapter this small memento for the token of appreciation. Thank you.
Thank you very much, sir. I'm really delighted. I was really delighted to be with being with you, and also I would like to thank you all for inviting me for this occasion. And thank you very much again. Good night, all.